Good morning, everyone. Don Gillis here with Emerson. I'm at the Copeland in Sydney, Ohio. Kind of wanted to walk through some parts and pieces of just a scroll, standard scroll. Go through like what I'm going to call the anatomy, if you will. Start out with some generic stuff you probably already know. I'm just going to walk through and kind of elaborate a little bit on it. Okay, maybe I'll touch on something you don't know. So first of all, I'm going to start out with the base there. What you're seeing there is what we call the lower bearing of it. That right there is where the shaft will sit down inside there. That lower bearing will be submerged in oil at all times. Something you can't see here is you're going to see a magnet of some sort. You may see it in documentation referred to as a dirt trap. It's just a magnet laying down there that if for some reason some particles float through there over the years, it attaches itself and keeps it out of any impurities out of that refrigeration system. Okay, so I'm going to set the base down. I'm going to grab my rotor here and my shaft all in one here. At the bottom of that shaft, there's those two little flingers. Think of those as rudders, if you will. If you can see that very well. See them like two little fingers there, boat rudders. The hole at the bottom of the shaft drilled out slightly smaller than the top of the shaft, giving that vortex effect. I want you to think of that almost like a tornado, if you will, drawing up through that straw as it opens up, okay? It's slightly flared at an angle there, which helps with that. It's moving 3,600 RPMs, almost like a barber pole effect with that centrifugal force. Oil goes up like a candy cane, spirals up there. If there is any lubrication that needs to be done along the way, you're going to have holes drilled in horizontally. Here will be our unloader bushing or our straddle bearing on top of there, pardon me. We have counterbalance weights top and bottom. Okay, so that's going to be in there. I don't think I missed anything there. Setting that down. That was actually one of my jobs out in Lebanon, Missouri last summer. I volunteered in the plant out there for a week, and that was my first station every morning, putting the rotors in and connecting them to the shaft and actually putting those little flingers in there. So we have this established. Let's go to our next piece, and that's going to be our straddle bearing. So if you see the dimples pressed on the outside of the shell of a scroll, that's where they're hitting at. That's where they're being machined at. They're dimpling inside there to keep that weight up there off of there, okay? You can also see a little hole right there. There it is right there. That is where that oil is going to drain back down after it comes in the shaft and slops around. It's going to lubricate the top of that straddle bearing. This is where the orbiting scroll is actually sitting on top of, okay? All right, so I'm going to put that in there. That sits like that. The next piece is going to be our Oldham coupling. The Oldham coupling keeps the orbiting scroll in orbit, okay? So it's nothing more. It's made of aluminum, and it's got 4 pegs on it. 2 of them are going to be for the top scroll or the fixed scroll. The 2 smaller of the pegs are going to be where it fits in the notches of the orbiting scroll. See if I can get that in there right. Without lubrication, it's a little... There we go. So that's on top of there. All right. Set that down there. Oops, I missed my unloader bushing. That unloader bushing is key. I almost missed it, okay? That goes in next over the top of the shaft. That unloader bushing is key because if you notice there's a little piece of steel. See if I can pull it out. There it is. That's inside there, okay, that naturally wants to go straight. We put that in there in that D shape, if you will, causing that to almost act as a spring, if you will, okay? So that's what we call our radial compliance, that left and right. So that tolerates any type of debris that might get in there. Debris could be defined as a droplet of refrigerant, okay? It senses that, separates the sides of the scroll set, which is referred to as the flanks, opens up. The higher pressure gas towards the center of the scroll set will kick it back out. Again, high pressure will go to low pressure, right? So it's going to take the least path of resistance. If it's a droplet of refrigerant, we've always said scroll tolerates a little better. Well, we don't want it in there, but it will tolerate a little better. It separates those flanks, causing that droplet of refrigerant to go back out into the compressor itself, hopefully flashing off from the heat of compression, okay? So I'm going to set this orbiting scroll on top of there. All right, I'm going to set that up there. There we go. And then the next we're going to have our fixed scroll. Fixed scroll, it's fixed, as we say, will be mounted down with these sleeve guides into the straddle bearing. okay, mounts it down. We say fixed scroll, but it actually moves. It moves 1 millimeter. So on startup, contactor pulls in, orbiting scroll starts to move around. There is a bleed port in the medium cell of the fixed scroll, and as it gets to the medium cell, it starts to, that bleed port allows this cavity here at the top of the fixed scroll to be pressurized. Does two things. Okay, it pushes the fixed scroll down that 1 millimeter, engaging the tips of the orbiting scroll and the fixed scroll. Okay, starts to pressurize it. It also pushes up the floating seal. Okay, all right, pushes that up to the bottom of the, almost grabbed the wrong thing, the muffler plate, which separates high and low pressure, pushes up against that, forcing that gas to go out to the top of the side of the scroll compressor. Okay, all right, so that's what it does. If for some reason, fun fact, if for some reason that compression ratio gets far apart, low suction gas specifically, it doesn't have enough pressure inside that cell to hold that floating seal up or push that fixed scroll down, it will then drop, causing the compressor to shut off. So actually, the floating seal is actually a safety device also. So I'm going to push that, see if I can push that down inside there. Okay, now it's all in one. Let me see if I can get this put back together. Kind of working quickly on this. Let me see, that's about right there, it looks like. And there we go. That's the top of that. On the top of here will be our, sure I'm not missing anything, we'll have the top plate, two safety devices, IPR, TOD. One's based on pressure differential, the other one's based on temperature. TOD, thermal operating disk, a bimetal that reacts differently, the two metals, by differently on temperature, separating that. Think of it as an orifice. Okay, it's blocking that orifice. The other metal gets too hot, possibly that TOD separates that, allowing that gas, hot gas, to shoot down on the inherent protector that's in the windings that goes off on high amps or high heat. You'll notice any AE bulletin that you read, depending on the model, that TOD is going to go off typically somewhere between 260 and let's say 280, always below that 300-degree mark where we start to lose our lubricity and cause friction inside the compressor, okay? The IPR, if you were to look at that in AE bulletin, you're going to see somewhere typically, depending on the model, 375, 225. That's a differential between high and low pressures. Okay, condenser gets mad at too high, it goes off. It keeps it from becoming a catastrophic problem and you know, causing more damage than needs to be. Shoots that hot gas again down on that inherent protector that's wired in series in the windings that goes off on high amps or high heat. Okay, so those are those two things. Now if we get into the 410A, that's going to be somewhere closer to 625 different pressures. Okay, but for most part, all other refrigerants and IPRs are pretty much in almost all of what we do, except when we get into the commercial air conditioning compressors, and I'll talk more about that at a later date. Okay, set that down on top of there. Last but not least, I know I'm running long, we've got the top cap. Nothing really to talk about here. Typically, you're going to have a deflector here somewhere, so when that gas comes out of that port at the top, it doesn't make that top any hotter than it already is if you've ever touched one of those. The other thing is, you might not know, is in this discharge port, you're going to have a check valve. Depending on what model it is, how big it is, the size of it, those check valves are going to vary. A very simple look at a check valve would be something of this nature. Obviously, this is a lot larger than that discharge line. We have a wafer here with holes. It's going to be stationary, okay, right inside that discharge port, okay, a lot larger line than this one, obviously. It's going to be there. On the back side of that, further away on the discharge line, this will be closer to the compressor, we're going to have a washer here. Notice this just has holes in it on the outside. Okay, unit shuts down, that washer is going to block that gas coming back to the scroll set, not allowing any of that re-expansion gas, jeopardizing our volumetric efficiency, which is key, right? Gas we've already pumped out, we don't want re-expansion gas in there, okay? So we block that out. And they come in all different shapes and sizes. In the larger models, commercial air conditioning and different models that we have, you're going to see them actually internally in that scroll set, because these shells become so much larger. We have to do something with that gas that's already inside the scroll, that's not beyond that check valve in the discharge line. And just some variances of that. This one, for example, here, okay, Rotolock style, got the sweat style. And they're all going to be set for different springs or different, depending on the mass flow, you'll have different shapes and sizes, okay? I know that was really, really quick. Don't want to make these videos too long. If you have any questions for me, feel free to email me. You can also put something in the comments. I hope you're getting something out of it. Have a great day. I enjoy doing these. Hopefully you're getting something out of it. Take care of each other out there. If you're in the field, be safe, lock out, tag out. Until next time, I'm Don from Emerson. Have a great day. Thanks, everyone. Bye.